Welcome back. Let's talk about the acidic nature of oxides. Before talking about the acidic nature, let us see what oxides are. Oxides are actually the binary compounds of oxygen having an oxidation number of -2 with any other element. The term binary means the compounds which consist of only two elements and one among them must be an oxygen. For example, all these compounds consist of only two elements, so they are the binary compounds, though they contain many atoms. And as one among them is oxygen, having an oxidation number of -2, so all these are oxides. Now, these oxides can be either acidic, they can be basic, or they can be amphoteric, or sometimes they can be neutral also. Leaving aside other types of oxides, let's focus on the acidic nature of these oxides. Those oxides which when added with water produces acids, we call them acidic oxides. For example, carbon dioxide upon addition of water produces carbonic acid. As carbonic acid is an acid which is produced from carbon dioxide, so carbon dioxide is an acidic oxide. Similarly, upon addition of water to sulfur trioxide, it produces sulfuric acid. And as sulfuric acid is a strong mineral acid and it's produced from sulfur trioxide, so sulfur trioxide is an acidic oxide. Such type of reactions are very common in inorganic systems with the name water addition reactions or hydrolytic reactions. And point to be noted is whenever you carry out hydrolytic reactions or water addition reactions, the oxidation number of an element does not change. As you see here also, in case of carbon dioxide, carbon has the oxidation number of +4, so is the oxidation state of carbon in carbonic acid. Same is true with sulfur trioxide and sulfuric acid. Now, the point is what can be the elements which can form such acidic oxides? For that, normally we say oxides of non-metals are usually acidic in nature. As you see from the periodic table, the portion which is yellow in color are non-metals, so their oxides are essentially acidic in nature, which means the oxides of carbon, nitrogen, phosphorus, sulfur, and the halogens are usually acidic in nature. But there are some exceptions. For example, carbon monoxide, nitric oxide, nitrous oxide, these are the oxides of non-metals, but they are neutral. Now, among the oxides of non-metals, that is the acidic oxides, acidic strength of such oxides is usually decided by number A, the oxidation number of element. Higher the oxidation number of that element, more is the acidic strength. For example, in these three oxides of nitrogen, as you see, the oxidation number is +3 in case of N2O3, it's +4 in case of N2O4, and it's +5 in case of N2O5. As the oxidation number is high for N2O5, so it's more acidic compared to N2O4, which is more acidic compared to N2O3. So the acidic strength trend is shown this way. In the same way, while looking at the oxides of phosphorus, we have P4O6 and P4O10. Oxidation number of phosphorus in each differs, and that's +3 and +5. So P4O10 is more acidic than that of P4O6. So this is the acidic strength trend. Similarly, we have sulfur dioxide and sulfur trioxide. Oxidation number of sulfur in sulfur trioxide is +6, while that in SO2 is +4. So sulfur trioxide is more acidic than sulfur dioxide. In the same way, while looking at the oxides of chlorine, we have all these oxides, and as the oxidation number increases from +1 to that of +7, so is the acidic strength. Similarly, while looking at these oxides, the oxidation number of carbon in CO2 is +4, in N2O5 it's +5, in SO3 it's +6, while that in Cl2O7 it's +7. So as the oxidation number increases, so is the acidic strength. Now, if the oxidation number happens to be same, then more the non-metallic character, more will be the acidic strength. For example, on comparing sulfur trioxide with selenium trioxide, as they have the same oxidation number of +6, but sulfur is more non-metallic as compared to selenium, since we know down the group non-metallic character decreases. So sulfur trioxide will be more acidic as compared to selenium trioxide. Similarly, we have Cl2O5, Br2O5 and I2O5. These are the oxides of halogens. So they have the same oxidation state of +5, but as we know, down the group non-metallic character decreases, so is the decrease in acidic strength. So that's why Cl2O5 is more acidic compared to Br2O5, which is more acidic compared to I2O5. I hope you understand it. If you like my videos, please do share and subscribe. Thank you.